Now example 3, we have a diagram which represents a lawn with a circular flower bed in the middle and a gravel path surrounding the lawn. The width of the gravel path is 1 metre and the other measurements are shown in the diagram. Well, they're not all in the diagram. Let's just decide where our lawn is. There's our lawn inside the small rectangle. It's the last page of our last lesson, so let's enjoy it a little bit. We've got the flower bed in the middle. Some nice red flowers. Notice that the radius of the flower bed is in centimetres, whereas the breadth of the lawn is in metres, as is the length of the big rectangle around the outside of the gravel path. Now, the width of the path is 1 metre. That information isn't shown on the diagram. So we know that distance is 1 metre. That distance is 1 metre. So that tells us something about that distance. It must be 8 metres, subtract that metre and that metre. So it must be 6 metres. So the length of the lawn is 6 metres. And we don't have the breadth of the big rectangle. Well, it must be 4 metres plus that metre plus that metre. So that is 6 metres. So a little bit of information that we needed to add to complete the information on the diagram. Now we are asked to find the area of the lawn. So the area of the lawn is the area of the big rectangle, subtract the area of the circular lawn. Sorry, it's the area of the little rectangle, subtract the area of the lawn. Now put in the formulas we're using for the area of the rectangle. It's length times breadth. The area of the circle is pi r squared. Now substituting into the formulas, 6 times 4, 6 times 4 for the area of the small rectangle, subtract the area of the circle, pi. Now remember the radius was in centimetres and we've put in dimensions in metres, so perhaps we'd better change this centimetre measure for the radius to metres. So multiplied by 80 centimetres is 0.8 metres, and we must square it. That'll become 24 minus 2.01, so I'm going to round that off to 22 metres squared. All the dimensions we multiplied were in metres, so hence the area is in metres squared. So part B is to find the volume of soil required for the flower bed if it needs to be 15 centimetres in depth. So there's the flower bed, which is circular in shape, and we want to put soil into it to a depth of 15 centimetres. So this is the cylindrical shape, so pi r squared h, or depth if you like. Forgot the squared there, pi. Now we'll stay in centimetres this time because we've got the radius in centimetres and the depth in centimetres. Now if you pop that into your calculator, now because it's volume, it's centimetres cubed. So 301,593 centimetres cubed. The second part of question B asks you to calculate the number of bags of soil required if each bag contains 20 litres. So remember, a litre was 1,000 cubic centimetres. So if one bag of soil is 20 litres and 1 litre is 1,000 cubic centimetres, so therefore each bag contains 20,000 cubic centimetres of soil. So the number of bags that we will need is going to be the volume of the flower bed, which is 301,593. That's the volume in centimetres cubed of the flower bed, divided by the volume of one bag, which is 20,000 cubic centimetres. And if you pop that into your calculator, now it gives you an answer of 15.0796, which is a bit more than 15 bags, and you can't buy a bit more than 15 bags, so you're going to have to round this up to 16 bags of soil. Now the last question is that the depth of gravel, well, it asks for the depth of gravel if 8 cubic metres of gravel is delivered and laid on the gravel path area. Okay, so we've got 8 cubic metres of gravel. Let's just think about that. That's volume. Remember, volume was equal to area times depth. So we're talking about the gravel path. Can we determine the area of the gravel path? We have the volume. We know that's 8. Can we find the area? Because we've been asked to calculate the depth. Let's go back and have a look at the diagram. Yes, I think we can find the area if you have a good look at it. You've got rectangle in there which is 8 by 1, another rectangle in there which is also 8 by 1, and two rectangles there and there which are 4 by 1, or you can say that it's the area of the big rectangle, take away the area of the little rectangle. So let's go back and do that. So area of the gravel, well, I'll do it by looking at the little rectangles. I had two rectangles that were 8 by 1 plus two rectangles that were 4 by 1, so that's equal to 16 plus 8, 24 metres squared is the area of the gravel path. So we've got volume equals area times depth. Transposing the formula, we've got depth must be equal to volume divided by area. It's not a very good V, let's just make it look more like it. Let's redo that whole thing. Volume over area. So substituting in the values, volume is 8 cubic metres divided by the area, which is 24. Cancelling out a common factor of 8, we've got 1/3 of a metre. Remember, volume was in metres cubed, area was in metres cubed, so 1/3 of a metre. What's 1/3 of a metre in centimetres? One metre is 100 centimetres. .3 centimetres. Well, that's the end of the last lecture for TEP023, and good luck with your exams, guys.